Welcome to the module related to the problem statements of loss statistics. So, let us have a look about that what we had discussed in the previous modules. We have gone through about the introduction about safety. We have defined that what are the different hazards and risk, discussed about the loss statistics. We had gone through the different method to calculate the accident and different kind of loss statistics. Because these loss statistics plays a very vital role while designing any kind of safety operation within the plant or any kind of process. We have gone through the concept of risk management and different control methodologies. We had a discussion about the hazardous substance rule in related to 1986. Now, in this particular module, we are going to discuss the various problems related to the accidents and loss statistics and other topics related to the study which we have gone through so far. So, let us have a look about the first problem. Now, here in this particular problem, this is related to the FAR, fatality accidental rate, and a process has reported FAR of 2. So, you need if an employee works standard 8-hour shift for 290 days per year. So, you need to compute the death expected per person per year. So, we are having the standard formula for this FAR. Now, this FAR is equal to number of fatalities into 10 to the power 8, this one, divided by the total number of hours worked by all employees covered. So, here you are having a shift of 8 hours per day. So, this one per day into 290 days per year, and we are having the FAR is 2 deaths per 10 to the power 8 hours. So, the FAR is so the death per person, this is the death, sorry, this is the deaths per person per year. So, this is the death per person per year is coming out to be 4.64 into 10 to the power minus 5. So, you can anticipate that 4.64 into 10 to the power minus 5 death per person per year based on the statistical information given to you in this particular problem. Now, let us have another problem. This problem says that if twice as many people used motorcycle for the same average amount of time each, what will happen to the OSHA incidence rate? Number 2, the FAR. Number 3, the fatality rate. Number 4 is the total number of fatalities. So, in this particular problem, the OSHA incidence rate will remain same because the number of injuries and death will double, but the total number of hours exposed will double as well. Sorry. Now, the second problem says that you need to calculate the FAR. Now, here the FAR remain unchanged for the same reason which we have discussed in part number A, that is related to the OIR. Now, the third problem says that what would be the fatality rate. Now, the fatality rate or death per person per year will double. The fatality rate does not depend on the number of hours exposed. And the last part covers that the total number of fatalities. So, based on the information, because twice many people use the motorcycle, the total number of fatalities will be doubled in this particular case. Now, let us have problem number 3. This problem says that if all riders used their motorcycle twice as much, what will happen to the OIR? Now, let us come to the problem number 3. Now, here the problem is a bit similar to previous one. Here the slide changed that if all riders they use their motorcycle twice as much, what will happen to the OIR and FAR, the fatality rate and the total number of fatalities. So, the OSHA incidence rate will remain the same, and the number of injuries and death that will be doubled, but the total number of hours exposed will double as well as far as FAR is concerned, the FAR will remain unchanged for the same reason which we have discussed for the OSHA incidence rate. Regarding the fatality rate will double because the riders they are using motorcycle twice. So, the twice as many as fatalities will occur within this particular group. The last part of the problem says that what would be the total number of fatalities. So, in that particular case, because the riders they are using the motorcycle twice as much, so the number of fatalities would be double in this particular case. Now, let us have another problem, that is problem number 4. Here a friend states that more rock climbers are killed traveling by automobile than are killed by rock climbing. Is this statement supported by the accident statistics? So, for this particular aspect, we require a couple of data, and these data are always available in the reference book. So, FAR for rock climbing, it is given that 3000, and FAR for automobile it is given that the 47. So, as per the data, it shows that the traveling by automobile, which is having the FAR of 47, is safer than the rock climbing. So, rock climbing produces many more fatalities per exposed hour than the traveling by automobile. However, the rock climbers probably spend more time traveling by automobile than the rock climbing. So, as a result, the statement is very ambiguous. That is, statement might be correct, but we may require some more data because it does not reflect any kind of uses of either rock climbing or the traveling by the automobile. So, sometimes you may say that some more data or some more statistical information is required to solve this particular problem. There are you may in this particular problem you may list to 6 different products produced by any chemical engineer that are significant benefit of the mankind. It's a very interesting question. So, there are maybe like you can say the penicillin, gasoline, synthetic rubber, paper, plastic, sometimes concrete, and you can say the all kind of food items, etc. Other problem says it's a bit long problem, you can say, that the following accident report has been filed, that the failure of a threaded 1.5 inch drain connection on a rich oil line at the base of an absorber tower in a large, that is having the 1.35 MCF per D. The gas producing plant allowed the release of rich oil, and the gas at 850 psi and minus 40 degree Fahrenheit. So, the resulting vapor cloud probably ignited from the ignition system of an engine driven recompressor, and a 75 feet high and 10 feet in diameter absorber tower eventually collapsed across the pipe rack and on 2 exchanger trains. So, the breaking pipeline added more fuel to the fire, and severe flame impingement on an 11,000 horsepower gas turbine driven compressor. Waste heat recovery and a superheated train resulted in its near total destruction. Now, here you need to identify the initiation, propagation and termination step for this particular accident. Remember, whenever we discuss about the initiation, propagation and termination, it all depends about the perception to perception of a human being. Sometimes engineering perspective may be different than a common people perspective. So, let us talk about the engineering perspective. So, initiation may be referred as the failure of threaded drain connection. Propagation, because once initiation start, let us discuss about the propagation. So, the release of rich oil and the gas and the formation of a vapor cloud, ignition of that vapor cloud by the recompressor, and the collapse of absorber tower across pipe rack. So, this is the propagation, and of course, the termination is the consumption of all kind of combustible material present within the plant periphery. So, by this particular problem, you can have a look about the different aspect of initiation and propagation. Now, let us have a look about the problem number 7. Here, a rock climbing club has 900 members working in a chemical industry. On average, each member spent 4 hours per day in driving and 2.5 hours per month in climbing. So, in 8 years, how many members will die due to this rock climbing aspect, road accident and occupational statistics? So, for this particular aspect, you may require certain data related to the fatality accidental rate, which we will utilize while solving this particular problem. So, here let us take the first example of rock climbing. So, number of fatalities is equal to FAR, that is the total hours climbing by all members in 8 years. So, these fatalities comes out to be 4,000 into 900 into 2.5 into 12 into 8. So, we have utilized all these statistical data. So, it is comes out to be 8.64 fatalities. So, this is attributed to the rock climbing. Now, let us have a look about the road accident. So, number of fatalities is again we are having the same formula. So, here we are having the 57 10 to the power 8 into 900 into 4 into 365 into 8. So, here you may expect 5.99 deaths with respect to the fatality. Now, in the next aspect, we are having the occupational accident. So, again we will utilize the same formula which we had discussed in the previous slide. So, the number of fatalities 1.2 upon 10 to the power 8 into 900 into 2 into 8. This is comes out to be 0.173 deaths. So, these are the answers for this problem number 7. Now, let us have a look about the next problem. Here, if an employee breaks their leg on a Monday and loses the rest of that day plus 3 additional days of work and is given restricted, or we can say the limited work task, and then loses another 2 days when their his cast is removed. So, here you have to calculate that how many days will be counted on lost day. So, here if an employee breaks their leg on Monday and loses the rest of day, the 3 additional day of work, that is the employee comes back on the Friday and then loses another 2 days when his cast was removed. So, as the day of injury or illness occurred is not counted as a lost work day because he was present in on that very day, the total number of lost day would be 5. So, you may take a note that for an incident that have lost time occurring over a longer period of time, weekend are counted as a working day, and the number of lost day is capped at 180 days. So, this is the aspect of this particular problem. Now, let us have a look about the next problem, that a company has 17 full-time employees and 3 part-time employees that each work 20 hours per week. So, this equates that 28,400 labor hours each year. Now, if a company experience 2 recordable injuries, then you need to calculate the OIR or OSHA incidence rate for this particular aspect. So, here let us have a look about that what OIR says. OIR is the number of injuries and illness multiplied by 0.2 million divided by the total hours worked by all employees during the period in question. So, OIR is equal to 2 because number of injuries are reported as 2 into 2 lakhs divided by 28,400 because the total number of hours worked by employees are 28,400. So, it is 14.08. So, this is the answer. So, for every 100 employee, 14.08 employees have been involved in a recordable injury or illness. So, this is the problem related to the OIR. Now, let us have a look about the next problem, that is problem number 10. That is using the previous example which we have discussed, that is problem number 9. Assume that one of the 2 recordable cases had lost work days associated with the incident. So, now you again need to evaluate the OIR based on this particular statement. So, again refer back to the original one which we had discussed in the previous problem. OIR is equal to 1 into 2 lakh divided by, because the total number of hours worked by the employees are remains same. So, it is comes out to be 7.04. This is the answer. So, for every 100 employee, 7.04 employees have suffered lost time because of the work related injury or illness. Let us see the other problem, that is problem number 11. So, a plant employee is 1500 full-time workers in a process with having the FAR of 5. So, how many industrial related deaths are expected each year? It is quite simple problem because we are having the FAR of this general formula. FAR is equal to number of fatalities into 10 to the power 8 divided by the total hours. So, it is given that FAR is given 5, then number of fatalities into 10 to the power 8 divided by 1500 into 2000. So, that is the number of fatalities are coming out to be 0.15 deaths. So, that is in other words you can say that one death is expected in every 6.6 years. That is the answer. So, here we have calculated this one. Now, let us take the problem number 12. Here, an airline industry claims that commercial airline transport has fewer deaths per mile than any other means of transportation. Now, do the accident statistics support this claim? First thing, in 1984, the airline industry posted 4 deaths per 10 million passenger miles. So, what additional information is required to compute FAR, a fatality rate, etc. So, you are here you are having the FAR for car riding 57, FAR for bicycle riding 96, and FAR for airline, it is given 240. Now, here let us solve this particular problem, that due to the high speed of aircraft, more miles are accumulated. So, on a peak hour basis, traveling by plane is approximately 4 times more dangerous than by travel. So, FAR, this need the total hours exposed. So, let us assume that average aircraft speed as 250 miles per hour, and the total hours exposed, they are 10 into 10 to the power 6 miles divided by 250 miles per hour, that is 40,000 hour. So, FAR, that is 4 death into 10 to the power 8 divided by 40,000, which is comes out to be 10,000, and this FAR is greater than 240. So, you can see that the problem is a bit severe. Now, let us see that the fatality rate. So, assume that a person travelled 350 miles. So, the total passengers 10 into 10 to the power 6 miles into 1 person divided by 350 miles. So, this is comes out to be 28,570 persons. So, the fatality rate is equal to 4 upon 28,570, and that comes out to be 1.4 into 10 to the power minus 5. This is a relatively very high value. So, this is I mean, you can say that we have calculated this fatality rate and it is more than expected one. Now, let us take another problem here. You need to look at this picture below, and you may need to identify as many as hazardous situation. So, here there are 2-3 figures are given to you. So, let us find out that hazardous situation. Now, this is a fire water valve, and cannot be operated because of the branch growing all around, which you can see in the photograph, and this restricted the operational ability of this particular valve, and valve is locked in a position with the branches of the tree. So, the general housekeeping of the trees has deteriorated, and trees are left to grow to the extent that they prevent the access to the critical piece of equipment. So, this is extremely hazardous scenario for this one. So, once if it is required to use this particular valve, then probably it may not be in a position to operate. Let us have a look about the another problem. Again, you need to look at the figure below or picture below, and identify the hazardous situation. So here the flexible hoses are used to connect the piping which do not fit together properly, remember. So also the flanges on the right, they appears to be missing at least one bolt, you can see, and the faces of the flanges do not align properly. So the hose behind it would appear to be homemade by attaching a flexible hose to a pipe using a cable tie. So this is again a very dangerous situation, and sometimes this kind of makeshift or a rough arrangement will not solve its purpose. So in this particular module, we had discussed various problems, some psychological problems, some numerical problems related to the loss statistics. And again, you can have a look of the first reference where you may find several other unsolved problems, and you may try those problems for your further reading. Apart from this, we have listed couple of more references to help you out to solve this type of problems. Thank you very much.